In this section, we will review the key regression algorithms available in Azure Machine Learning Designer. The first algorithm is the linear regression algorithm. This algorithm attempts to establish a linear relationship between one or more independent variables and a numeric outcome or dependent variable. With linear regression, there are two popular approaches to measure error and fit the regression line: ordinary least square method and gradient descent. The ordinary least square method computes error as a sum of the squares of distance from the actual value to the predicted line, and it fits the model by minimizing the squared error. This method assumes a strong linear relationship between the inputs and the dependent variable. In gradient descent, the approach is to minimize the amount of error at each step of the model training process. The second algorithm is a decision forest algorithm. The decision forest is an ensemble learning method for regression. The algorithm works by building multiple decision trees, and each tree in a decision forest outputs a distribution as a prediction. An aggregation is performed over the ensemble of trees to find a distribution closest to the combined distribution for all the trees in the model. The algorithm supports some of the same hyperparameters discussed for the multi-class decision forest algorithm, such as number of trees, maximum depth, and the list goes on. The next algorithm is a neural network regression algorithm. This is a supervised learning method and therefore requires a tagged dataset, which includes a label column. Because a regression model predicts a numerical value, the label column must be a numerical data type. A default architecture for the neural net is fully connected neural network with input layer, one hidden layer, and the output layer. The algorithm also supports the same hyperparameters like number of hidden nodes, learning rate, and the number of iterations that was discussed for a multi-class neural network algorithm.